What is going on, guys? Welcome back. In this video today we're going to build a simple Neofetch clone in Python. So let us get right into it. Alright, so we're going to build a simple Neofetch clone in Python today. Now, for those of you who don't know what Neofetch is, it's a simple command line tool that displays some system information. So I can run Neofetch here and we can see I get a Pop! OS logo. I get the name and version of my operating system. I get the kernel version, the uptime, the number of packages, my shell, the resolution of my monitors, the window manager I'm using, the terminal emulator I'm using, my CPU and GPU information, and also how much RAM I have, including the RAM usage. So that is the tool that we're going to try to build a clone of, a minimalistic one, not with all the features, not with all the details, but I can actually show you what this is going to look like in the end because I already prepared the code for this video. And this is going to be our final result. Now, in my case, I didn't want to mess with the whole ASCII art of the various operating systems, so I just included an orange 9 for neural 9. But besides that, you can see we have the operating system, we have the kernel, uptime, packages, the shell, the resolution of the monitors, the desktop environment or window manager, the CPU, the GPU, and the RAM information. Even though the formatting is different, even though not all the details are included, but that is going to be the minimalistic clone that we're going to build in this video today. So let's remove this and start writing it from scratch. The first thing we need to do is we need to install a couple of packages. For this, we're going to say pip or pip3 install. And we're going to install rich, which is used for coloring and aligning and tables and displaying everything in a beautiful way. We're going to also install the package distro to get some information about the operating system. We're going to install screen info to get information about the monitors. And we're going to install, what was the other one? psutil to get information about, I think, was it processes or memory? What did I use this for? Yeah, for the memory. So these are the packages we're going to need. Install them. And once you have them installed, open up a new Python file. In my case, I'm going to call this main.py. And here now we're going to start with the import. So we need to import a bunch of stuff from rich to make this look good. And then we're also going to import other modules or packages to get the system information that we want. So first of all, we're going to start with the core Python packages. We're going to import OS. We're going to import platform. We're going to import socket. Socket is useful for the host name. We're going to import, what else was it? We had RE for regular expressions. This is going to be relevant for finding exact GPU information. And then also from datetime, we're going to import datetime. From the install packages, we're going to start by importing distro and by importing psutil. Then we're also going to import from screen info, get monitors, and I think the rest is just, no, actually I forgot one thing. Subprocess is also important. Subprocess. And the rest is going to be from rich. So we're going to say from rich import box, from rich.console import console, from rich.table import table. All of this is just styling related. So from rich.panel import panel, from rich.text import text, from rich.align import align. All of these with a capital, with uppercase starting letters so that we have a class. And I think that should be it for the imports. What we're going to do now is we're going to write multiple different functions that get pieces of the information that we need for us, and then we're going to combine them into an output. So we're going to start by defining a function get uptime. And get uptime is going to take our time right now, the current timestamp, and it's going to take the boot time, and then it's going to calculate the difference and format it accordingly. So we're going to say that the boot time of our system is going to be equal to psutil.boot time. Then the current timestamp is now, and now is going to be datetime.now.timestamp. And the uptime in seconds is going to be the difference between now, or actually let's turn this into an integer, the difference between now and the boot time. And what we want to do now is we want to make divisions so that we get the days, hours, minutes, and seconds if we're interested in that. And we do that by using the diffmod function. So diffmod basically gives you the floor division result and also the remainder. So you can see the results. The first thing you get is the floor division result, and then you get the modulo operation result. So we're going to say that the days and the remainder are going to be equal to diffmod, and we're going to divide the uptime that we have by, and now how do we choose the number? Obviously a day consists of 24 hours, an hour consists of 60 minutes, and then a minute is 60 seconds. So we can open up a calculator and we can say 60 times 60 times 24, that is going to be 86,400. So 86,400, that's going to be the amount of days. The remainder is going to be the seconds that remain after doing this. For this, we're going to say then hours remainder is going to be diffmod of that remainder. And 3,600, so 60 times 60. And then we're going to say minutes and seconds is going to be equal to diffmod remainder 60. And then we're going to craft a string, uptime string, which is going to be the following, just a simple formatted string, days D, hours H, minutes M. I don't want to display the seconds, so you could actually also just make this an underscore, a placeholder, doesn't really matter, but we can leave it like this as well. So let's return this uptime string, and let's test it to see if we did this correctly. So let's print the get uptime function call, and I get 3 hours 37 minutes. So when I close this, open up a new terminal, Neofetch, I get 3 hours and 37 minutes. Perfect. So that seems to work. Next up, we're going to get the shell version. Now, how do you get the shell that you're currently working with? You just get the environment variable shell, at least on Linux. So you just echo $shell, and you can see I'm using user bin ZSH or zshell, or however it's pronounced. And we can do that in Python as well. So I can just say get shell, and I can say that the shell is equal to OS environment get shell. And if I get something as a result, of course, let's open up an interpreter to show you what happens. If I get this as a result, let's import OS. OS environ get shell. I get this, but of course I'm only interested in the Z shell in the end. So I'm not interested in the whole thing. I'm interested just in the last 3 characters, but not always, because bash has 4 characters. So what I'm going to do is I'm going to say OS path base name. That's going to be it. And this is going to give me just what I'm looking for. So we're going to say that if, or let's say shell, or let's say OS path base name of shell, if shell, else n/a. So we don't know what it is if we don't find it. And of course we want to return this. All right, so let's give this a try as well. Print get shell, and let's see what we get here. I get Z shell. Perfect. The next thing is the desktop environment. So what is my desktop environment that I'm using? And for this, we're going to, or desktop environment / window manager. For this, we're going to say get DE, and we're going to just get another environment variable. So I can open this here. If I echo xdg underscore current desktop, either that or the other one is going to be set. So that is one of the variables, and another one could be desktop session. So actually, this is the correct one. I'm using i3 gaps. So maybe I want to do the second one first. We're going to say OS environment get, and we're going to try to get desktop session. And if this does not exist, if I get nothing here, I'm going to say or. If you use or with strings, by the way, for those of you who don't know this, if I have hello or world, I'm going to get hello. But if I have an empty string here, I'm going to get world. This is quite interesting. I don't know if all of you know this, but this is why we're doing it like this. OS environment get. The other one was xdg current desktop. All right, so that's the desktop environment, and we're going to return de if de, else we're going to return again n/8. All right, perfect. The next thing is we want to get the resolution. So the resolution of my monitors is going to be get resolution. And we're going to say here now we're going to use our package that we installed. We're going to say try monitors is equal to get monitors. And then we're going to say resolutions is going to be equal to, and then we're going to have a list, and we're going to have formatted strings in here. And these are going to be the monitor width times the monitor height, and that for every monitor in monitors. So these are going to be the resolutions, and we're then going to just return them joined on a comma. So join resolutions on a comma. And if we get a problem here, so exception, if something goes wrong, we're going to just return, guess what, n/8. Perfect. Then we also want to know how many packages we have. Now, I'm only going to focus on dpkg, so I'm not going to focus on snap or anything else. But we can run the following command, dpkg -- get selections, and I get all the packages that I have installed. However, I'm not interested in the packages themselves. I'm interested in the length of this output if I split on line breaks. So we're going to say here, get packages. We're going to try, and we're going to say the result of our function call will be stored in here, subprocess.run. And I'm going to run the following command, dpkg -- get selections. And then we're going to say whatever we get as std out is going to be directed to subprocess.pipe. Then stdr is going to also be subprocess.pipe. And text is equal to true. So we get the result. And then we're going to say if the result dot return code is equal to 0. So if everything worked well, we're going to say packages are going to be equal to, actually, we're going to say line for line in result, std out split. So we're going to do a line break split here. If we have a line that's not empty, we don't want to have empty lines. And then we're just going to take the length of that. That's going to be the number of packages. We're going to return string packages. And again, if we have some problem, as always, we're going to just return n/8. Then we're going to get the operating system. This is the easiest one, I guess. I don't even know if we need a function for this, but let's just create one. Get OS is going to do the following. We're going to say return distro name and then pretty equals true. That's that. And then we're going to also define a function here for the GPU. We're going to say get GPU, because for the CPU and actually for the CPU and for the actually let's create one for CPU and RAM as well. I didn't do that in my prepared code, but if I do it for OS, I can also do it for the CPU. So the CPU is def get CPU. For the CPU, what we're going to do is we're going to just return platform.processor. That's it. There you go. And then for get RAM, we're going to say return formatted string. And a formatted string is going to contain the following value, round. We're going to round psutil.virtual memory total, so the total memory, divided by 1024 to the power of 3. And that's going to be gigabytes. Yeah, that's basically it. That's going to be our RAM calculation. And then we have finally the get GPU function. This function is a little bit trickier if you want to have it generalized. If you just want to have it for your system, it's not too difficult. But what you basically have to do is you have to run the command lspci, list all the PCI devices, and then you have to extract the line where you have your GPU. So in my case, this is something like VGA compatible controller, and then we're going to get this GeForce 3060 Ti. So we're going to find that line, and then we're going to extract the information. So how do we do that? We go to get GPU, and we say try result is equal to subprocess run. We're going to run the command that I just talked about, lspci. And we're going to, again, do the same thing. std out is equal to subprocess pipe. std error is equal to subprocess pipe. Text is equal to true. And then from the output, we're going to use a regular expression to find the GPU lines. So GPU lines is going to be equal to re find all. And the pattern is going to be the following. It's going to be a regular expression pattern. VGA compatible controller, or we could also say 3D controller oftentimes, colon, and then just something in, actually let me see that again, lspci grab VGA yeah, that's fine. So we're going to just do it like this. And then we're going to say result.stdout is going to be what we apply this onto. And we're going to ignore the case. So ignore case. Great. So to get the GPU names, we're going to just say GPU names is equal to GPU1 for GPU in GPU lines. And we're going to just take this line and we're going to concatenate GPU names. So we're going to say GPU names are going to be joined on commas. If GPU names, else, guess what? NA. All right, and if we get some problem, again, guess what? NA. So I think that's it for the functions. I hope I didn't forget anything. I mean, maybe we should say here, if let's say CPU is equal to platform.processor, and then let's say CPU if CPU else NA. Here we should always get an output, and here as well, I guess. Let's just assume that that's the case. So now we have to care about the styling. And for this, we're going to open up a main section here. Do I have a snippet for this, actually? I don't think so. I don't know. But what we're going to do is we're going to say that the console is going to be equal to a console instance. we're going to get all of the information. So we're going to say OS info is equal to get OS. We're going to say host is equal to socket. Actually, this is one that we don't have as a function. So for the sake of completeness, we're going to also say get host. And we're going to say that that is return socket.getHostName. So it's going to be get host. Then we're going to say kernel. Actually, for kernel, we also don't have a function. So let's say get kernel is going to be equal to return platform dot, what was it? Dot release is the function. So get kernel. Then we're going to have uptime is equal to get uptime. Then packages is going to be equal to get packages. Then shell is going to be equal to get shell. Then resolution going to be equal to get resolution. And then DE, actually in my case it's a window manager, but let's call it DE because most people have a desktop environment. GPU is going to be equal to get GPU. Or actually, let's start with the CPU first. Get CPU, get GPU. And then memory is going to be equal to get RAM. So that's the information. And now all we need to do is we need to somehow display this in a nice way using rich. So we're going to say table is going to be equal to table. We're going to say show header is going to be false. We're going to say there is not no box, so box is none. And we're going to define a padding of 0 and 1. That is just the table itself. And then we're going to decide on two colors. One is going to be the color of the, what would you say, the identifier, so OS, host, kernel, and so on. And then we're going to have another one for the values. So we're going to say label style, label, let's call it label color, actually, is going to be bold and cyan. And then value color is going to be just white. And now we're going to add all the information to our table. So we're going to say table add row, and we're going to add a text instance. So text, and the text is going to be OS, for example. The style of that is going to be label color, and text is then going to also be OS info, and the style here is going to be value color. So that's basically it. Now we're going to copy and paste this a bunch of times, and we're going to do that for all the different things. We're going to do that for host. We're going to do that for kernel. We're going to do that for uptime. We're going to do that for packages. We're going to do that for shell and for resolution, and for desktop environment and window manager, and for CPU, and for GPU, and for the memory. Actually, let's call it RAM. And of course, we need to change this here as well. So that's going to be host, that's going to be kernel, that's going to be uptime, that's going to be packages, that's going to be shell, that's going to be resolution, that's going to be DE, that's going to be CPU, that's going to be GPU, and that's going to be RAM, or actually memory. So that's a table, and the only thing missing now is the logo, and then also, adding everything together in a layout. So we're going to say here, the logo I'm going to copy and paste here because I don't want to type this out again. So I'm just going to do it like this. That's the logo, and it's deliberately not indented so that it is displayed like this. And then we're going to say logo text is going to be equal to text logo, and the style is going to be, in my case, the closest to orange, or in my theme it actually is orange, but in general the closest is yellow. Actually, let's do bold yellow. And then we're going to say the logo panel, so the rectangle around it is going to be a panel. We're going to fit this panel to the logo text. The border style is going to be yellow. And the padding is going to be 0 and 2. Perfect. And now finally we say layout is equal to table grid expand equals true. Layout, we're going to add the columns, because what we basically do now is we create a table, and we're going to have the logo on the left side, and we're going to have the other stuff, so the information on the right side. We're going to say add column, justify equals left, and ratio equals 1. Then add column, justify left, ratio equals 4. And then we're going to say layout add row. And we're going to have logo panel and table. And then we're going to say console print align left this layout. That's it. So I hope this works. Usually I have some mistakes in here, and this time is no exception. I didn't close this when it came to the memory, so, or actually I did. What was the issue again? Closing, oh, I didn't close something else, which is the round function. Here I have an unexpected indent, so 128, yeah, okay. That's not too much of a big deal. There you go, works. So we even get I3 gaps now. We get, actually this is not what I was, this is just the CPU architecture, so maybe I should do some more work to get the actual CPU. So maybe that's not enough. Yeah, okay. I leave this as an exercise for you guys if you want to figure out how to actually get your CPU name in here. In my case, it just gives me the architecture. But yeah, this is how you can build a minimalistic clone of Neofetch. And I can even go out of this application here, run this to get different colors. Now it's orange. Yeah, this is how you can build your own little Neofetch that you can customize however you want. So that's it for today's video. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching, see you in the next video, and bye.